All right, welcome to Chapter 3, Section 7, Solve Systems of Equations. And this is for Math 8. All right, so a couple of things, just going over the screen we see here. On your student screen, you are going to see a due date right before attempts here. I don't see it on the teacher preview, but you will see it on your screen. So it'll just let you know when this assignment was due or is due. The next thing we see is the attempts here. So I'm on attempt number 1 of an unlimited attempts. This means I can try this assignment as many times as I would like, and that means submitting it as many times as I would like. We do not limit that. The number of questions just tells you how many this particular assignment has. So this one has 3. Depending on the section, it should be anywhere from 1 to 10 questions. Just depends on how many were available. Grading policy is best score, so you get to keep the attempt that has the best score on it. And partial credit is enabled, so if I answer 1 of 3 questions, I get credit for my 1 question. Down here it says, please remember, once you start your homework, you must finish it before you can work on anything else. So what that means, so if I click Start down here, on the student screen, so you won't see this on my screen here, but on the student screen down here, you will see Submit Assignment button. So that's always what you want to click when you're leaving this screen. If you're taking a break, if you're going to come back to it tomorrow, whatever's happening, even if you've only worked on 1 problem, you click Submit Assignment. There's a couple of reasons for this. The big one is it won't go in the grade book and let your teacher see what you've been working on until you click Submit Assignment. So it makes no effect in the grade book until you click that button. The second big reason is what that other screen was saying, is that the system is going to lock you out of every other assignment until you click Submit Assignment. So it assumes that you want to continue to work on this 1 attempt until you click that button. So, and remember, you have unlimited attempts, so you can always come back in and try again. Wherever you left off, wherever you clicked Submit Assignment button is where you're going to start again. So if you already did number 1 and you're working on number 2, when you click the Submit Assignment button and come back in, that's where you're going to start working. So it's going to save your progress also. All right, so on the side here, we have explanation, example, and message. So explanation is quite literally going to explain this problem to us. So you're going to lose your question attempt because it's not going to give you the answers and then tell you to go type them in. Okay, so hopefully that makes sense to everybody. You're going to get an X on here. You're going to have to come in on another attempt to try that one. Example will quite literally show you a problem type just like you're looking at, and it'll give you an example of what you're trying to do here. So with this one, we're categorizing types of solutions. So there's 3 types of solutions. There's exactly 1 solution. This occurs when the lines intersect at a single point. So we can kind of see this happening. There's 1 solution, 1 point that works for both lines because that's where they cross, is at that 1 point. So we call that exactly 1 solution. Infinitely many solutions occurs when 2 lines are the same. So that means it's 1 line right on top of the other one. They're kind of lying right on top of each other. So any point on 1 line would also be a point on the other line if they're literally the same. They're lying right on top of each other. So we call that infinitely many solutions. And then no solution, which we look at, is this occurs when the 2 lines are different and parallel. So they can't just be different, meaning they're not the same line. Like this one, we can see it says L1 and L2. That means line 1 and line 2. So this one, there's a line right on top of the other one. Well, now we have line 1 and line 2, so they're different lines and they're parallel, meaning they will never intersect. They're never going to cross each other. But it's more than just not intersecting, because we can also have lines going in completely different directions, like different planes, and they would never intersect. We call that skew. But parallel lines are in the same plane, like if we think of a piece of paper as a plane or the top of your desk as a plane. So there are 2 lines that are on the same plane, but they're lines that would never intersect. If we think of the sides of a table, right? They shouldn't ever come together unless it's a kind of wonky shaped table. But we can even kind of picture a table here if we wanted to. So here would be the front and the back of the table, right? They shouldn't intersect. All right, so we're going to go ahead and close this. That's the explanation. Gives us a little background on what to do here. You can click on example again if you want another example. You can also message your teacher straight from this screen. So it'll attach the question when you message them. Okay, so let's go ahead and classify these guys just like we were just talking about. So if we look at this one, we can see we have L1 and L2. So there's 2 lines here. I can't see them both because there's one right on top of the other. So remember, just like we were just looking at on that other screen, if we have the same line any point for line 1 is going to be a point for line 2. They're lying right on top of each other. So any solution works. So that means infinitely many solutions. Whichever number we pick will work for both equations or both lines. So if we look at this guy in the middle here, we have 2 lines and they're crossing at this one point. So there's only one point where they actually have the same solution. So we say this has exactly one solution, and then we have to give the coordinates of this one. So we have to fill this in if we choose this piece here. We didn't fill it in over here because we didn't choose this option. So now I have -2 and -3. So -2 is the x, because I went left 2, and then I went down 3, so that's my y, -3. All right, these two pieces definitely are different lines. They're not one right on top of the other. I can see L1 and L2 very clearly. They're different lines, and they are parallel, meaning they're the same distance apart. Those two are never going to come together. They're going to continue to go up, like side by side each other forever and ever. So they're not going to have any solution. There's no point on line 1 that is also on line 2 because they never cross each other. All right, so let's go ahead and check that and continue. Okay, so we're actually going to graph this. So we have our y equals mx plus b form. So remember, this is our slope-intercept form, and we've been using this now for a couple weeks. And we just used it on the last video as well. So I'm kind of color coding this just a little bit. So this is our slope, m is our slope, and b is our y-intercept. And we want to remember these definitely, and I know I get a little obnoxious in class about it even, because if we don't remember these pieces, it's going to be very difficult to graph them. That makes it so much easier to graph if we know what these pieces represent. So let's go ahead and take a look at these two equations we have. We have y, why didn't I change? Y equals x and y equals x. So I'm color coding it again because I like my color coding. So it's -3 for that first one, -x for the second one. And remember, that means -1. When I don't see a number there, it means it's a 1. And then for my b here, I have -5 and -3. So again, I've just color coded it so we can kind of easily match this up. The slope is always next to the x. It doesn't actually matter if these are kind of flip-flopped in order. We're always looking for the x, and that's going to be my slope. My starting point is the y-intercept. So I start here. This is my starting point. And we're going to do both equations. So let's go ahead and do the points here. So for my first equation, my y-intercept is -5. So I'm going to go down to -5 and I'm going to put a dot. My second equation is -3. So I'm just doing both y-intercepts at the same time. Okay, now let's look at the slope. And remember, if I don't see a number under there, it is a 1. So this is showing me, and just to be clear, this is a direction system. Again, I just went down 5, I went down 3. So now, from these points, from -5, I'm going to go down 3 and right 1. Again, just giving some directions. So from 5 here, I'm going to go 1, 2, 3. So I'm going all the way to the bottom. Ooh, I can't go to the bottom, can I? Now, can I still graph on the corner? Of course I can. What I can do is I can click this plot a point, and I would have to know where I'm going is the main thing. I can't just put in -3, 1. That's not going to plot correctly. So I'd have to know which point I'm landing on to plot it. But the other thing I could do is instead of going down 3, what I could do is go up 3, and instead of going right, I could go left. I just flip-flopped those. So what it does is it actually moves the negative down to the bottom, which is okay. We're allowed to do that. So I can go 1, 2, 3, and 1. It will still land the same. So this one would actually be right here, 1, 2, 3, and then 1. So it'd still be in a line. This still works. 1, 2, 3. I want to make sure I did that right. 1. Yeah. All right. So this one, I have -1. So I'm going to go down 1, and I'm going to go right 1. From -3. So let's go ahead and connect this because I'm worried it's getting a little confusing on the two lines. So this was one line. Now I'm going to do my second line. I'm going to finish. So here's my y-intercept, 1, 1. So I'm going to go ahead and connect these, and there we go. Now we can see where they cross. So the main thing is we want to make sure that we can see that there's a cross happening here, and I can see it's definitely a -1, -2. So I go over here and I click this and I go -1 and -2, and that is my solution. If they didn't cross, if they were parallel, I'd click no solution. If they landed right on top of each other, so they were the same line, then I'd click infinitely many. So you notice there are these options here. I could have had these situations happening to me. Let's go ahead and click check, and we are good to go there. All right, so let's erase this. We're going to start over here. Okay, so y equals x. Y equals x. I don't know why I'm giving myself so much space there, but I am. It's already there. All right, 2. Ooh, and we need to fix that second one, don't we? All right, so let's talk about that really quick because I started to write this down without really thinking about it. So this is -2x equals 6. So -2x plus y equals 6. Well, in order to use this slope-intercept form, I need it to equal y. I have to solve for y. So this one is pretty darn easy to solve for y. The only thing on the same side there that we don't want there is this -2x. So I'm going to go ahead and add 2x to both sides. Anything minus itself cancels out. -2x, +2x, they cancel. So y equals 2x plus 6. Be careful, don't combine these two together because one is being multiplied, that's what 2 times x means, and then plus 6. So if we think of PEMDAS, I can't add the 6 until I've done this multiplication because I have to do multiplication division before I can do addition subtraction. So combining like terms is a rule in PEMDAS. That's where we get that idea of like terms. It has to do with what's happening to that number. All right, so now that I have my equation here, I can start to compare, and I'm just going to put it up top so that, you know, it's easy to compare here. So now I know that my slope is 2, and I can go ahead and put my y-intercept in. So this one was +1. Remember, that was the first equation here. I'm just kind of writing them out of order a little bit. And we have +6 for the second one that we just found. All right, so remember, this is our starting. We're going to start here, and then we're going to move on the y-intercept. Okay, so this one means I'm going to go up to 6. I'm going to go up to 1 here. This guy tells me I'm going to go up 2 from the 6 point, and I'm going to go right 1. From 1 for this equation, I'm going to go down 1. It's a -1. I'm going to go right 2 because it's a +2. So let's go ahead and kind of do that. I'll do one equation at a time because I think last time it was a little confusing. I was doing too many ones. So let's do this top one first. So we're going to start at 6. So I'm going to go right up to 6 and I'm going to put my dot from 6. Now I'm going to look at the slope here. I'm going to go up 1, 2, and I'm going to go over 1. Let's go ahead and connect these lines like that. All right, now let's look at the second one here. I'm going to go up 1, put my point, and then I'm going to go down 1 and right 2. Down 1 and right 2. And I'm going to go boom, boom. And there we go. We have another single solution. They definitely cross right here at -2, +2. So, and I can click that button over there, but I can also type this in if I want and put commas, and it'll actually fill the boxes and create them for me, just like I just did there. So I didn't click this one, but I can click this and just put the numbers into the boxes they give me. So it just kind of depends on your preference there, what you want to do. All right, so that was section 7. I will see you in section 8.